Hi, my name is Jeff Orrock. I'm the meteorologist in charge here at the National Weather Service office in Wakefield, Virginia. And on this edition of Whether You Want to Know or Not, we'll be looking ahead to the 2023-2024 winter. I'll be sharing with you the outlook from the Climate Prediction Center and trying to help it make sense of what it might mean for our local weather here in the Mid-Atlantic region. So let's jump right into it. So the winter outlook from the Climate Prediction Center, looking at precipitation, is calling for above normal chances for basically above normal precipitation. If you notice, they're forecasting an enhanced probability that there could be above normal precipitation really across the entire deep south and then moving up into the mid-Atlantic region with the highest probability of seeing a wet winter along the coast, with the probability decreasing as you get a little bit further inland across the Commonwealth and parts of North Carolina. So obviously this lends itself to maybe an increased frequency of coastal storms, with you seeing the above normal precipitation across the southeast U.S., you might expect that we might see a few more storm systems forming in the Gulf of Mexico, coming across the Florida Peninsula, and then coming up the eastern seaboard, potentially as nor'easters or coastal storms as the winter wears on. So we'll see how that plays out, but it does look like, based on the pattern, we could see an increased frequency in coastal storms this winter. But does that mean snow? Not necessarily so much. Looking at the temperature outlook for this winter, they are predicting that there's a above normal probability that the temperatures will be above normal. Notice how the confidence here is not as strong. There was definitely more confidence in the precipitation being above normal versus the temperatures being above normal. And that's because our winter temperatures have a lot more variability, say, than precipitation does. So we'll see how this plays out. This definitely does not mean we will not see a snowstorm. What it does mean is that maybe when you're looking at the months of December, January, February, on average, when you average it out, the winter season might end up being just a little bit above normal. However, we are still going to see cold spells, cold air outbreaks during the winter like we always do. So it's just a matter of timing between the moisture when it lines up, can it connect with the cold air? So we'll see how it goes. So just because there may be a probability that the temperatures could be above normal this winter does not mean there won't be any snow. So we'll talk a little bit more about that. Now, when we think about the above normal precipitation that is predicted this winter, or the confidence that it could be above normal precipitation, this is very tightly tied to El Nino. And El Nino is in effect. We've had El Nino ongoing for quite some time. It influenced the hurricane season. And this winter is expected to be influenced by what they call a moderate El Nino. So it has to do with the fact that the water temperatures out over the equatorial Pacific are warmer than normal, increasing the shower and thunderstorm activity out there. And so with it being a moderate El Nino, and there's even a chance that it could be even a strong El Nino this winter. In a 1 in 3 chance it could rival some of the strongest El Ninos since 1949 to 1950 winter. So we'll see how it goes, but it is a substantial, decent El Nino that is ongoing in the Pacific. So there's good confidence that this is going to impact our winter throughout the next several months. What you notice here is that when you have an El Nino ongoing in the Pacific, it does cause fluctuations in the jet stream, and it does actually cause it to be maybe a little bit more amplified. You do see more a kind of a dipping of the jet stream or troughiness across the eastern seaboard. And so what this does is this does help to generate more coastal storms. Remember, coastal storms are really driven by cold air getting over top of the warmer water. You have the jet stream in play. You can start to develop nor'easters and coastal storms. When that happens, you can definitely increase the storminess across the entire South and even up into the Mid-Atlantic region. So with it looking like this is going to be the pattern that's going to hold this winter, we are expecting kind of this jet stream to be a big player and bring us maybe an increased frequency of precipitation and perhaps maybe even an increased frequency in coastal storms. And most of you guys listening know that our biggest snowstorms usually do come with some type of nor'easter or coastal low as it tracks off along the coast. So we'll see if there's some opportunities this year, or maybe more opportunities to maybe get that moisture up here, but then it has to link up with the colder air. And of course, in the Pacific, what is going on is the water temperatures are warmer than normal, and because the water temperatures are warmer than normal out here in the Pacific, it does increase the thunderstorm activity. So you put a lot of heat from the low levels of the atmosphere, you push that up into the upper levels of the atmosphere where the jet stream is, and so when you have this anomaly going on out here in the Pacific Ocean with all this thunderstorm activity, you can expect all this heat being pushed up into the upper atmosphere to basically influence the jet stream, and to kind of increase things, kind of amp things up, and that's exactly what's going to be going on this winter, with maybe a little bit more amplified jet stream helping to increase the storminess across the deep south. And this just kind of shows you the bigger picture of how not only for us, but El Nino actually impacts weather really across the entire globe. And you notice here in Alaska and parts of the Pacific Northwest, they can actually be a little bit warmer than normal, where across a lot of the deep south, we're typically cool and maybe a little bit wet. But again, the stronger signal with El Nino is definitely for precipitation. Now, when you look at all the different El Nino years and you kind of clump all those winters together, you kind of see where has there been increased snowfall across the U.S. during El Nino versus, let's say, compared to normal. And you do notice that in a typical El Nino, you do see some increased snowfall, especially across the inland areas of Virginia and North Carolina, across the mountains where, you still have the cold air. You can increase the probability of snowfall. Even in central Virginia, you see some blues here where you say, okay, on average, El Nino, we do sometimes see a little bit more snow, here in Richmond and Louisa and places inland than what we would typically see in an average winter. As you get closer to the coast down here towards Norfolk, notice that signal kind of goes away. You don't see nearly as much blue. Whereas up in Maryland, once you get up to Salisbury and then move up into the Delmarva, you still have some of that blue. So again, you can kind of envision these low pressure systems or these nor'easters moving up the coast. And as they move up the coast, they're pushing the moisture inland. And if there's enough cold air, you can actually start to squeeze some snowfall out of those systems, where as you get further east and closer to the ocean, you could be getting a little bit more rain, that rain snow line falling somewhere across central Virginia, as it always does. So we'll see how that plays out. The main thing about our winters is there is a lot of variability. Some winters are very snowy. Some winters, have very little snow at all. And even the same thing is true for some of our El Ninos. Some El Ninos are snowy and some of them not so much. So let's look at some of that variability across central Virginia. So this is looking at Richmond, and we're comparing a normal winter without, either, El Nino or La Nina in effect. So basically a normal winter. Nothing going on in the Pacific Ocean. Everything is normal. And you can see our medium temperature is about 38.5 degrees. During an El Nino pattern like we're in right now, notice how the temperature is still about 38.5 degrees. So this basically shows you that there's not a lot of influence of El Nino on our temperatures. Basically, our temperatures are much more variable in the winter than what they are other times of year, and so there's not a huge signal there during El Nino that we see much of a difference in temperatures. Now, you do notice during a La Nina, which is the opposite situation of what we have right now, the temperature actually is quite a bit warmer, and we're not in a La Nina right now, but there is a signal that during a La Nina, when the Pacific Ocean is cold, we can actually see above normal temperatures here across central Virginia. Now, when it comes to snowfall, you do see a little bit more of a signal. Again, here in the middle represents a normal winter, where there's no El Nino or La Nina affecting us at all. So the Pacific Ocean's we'll say a normal cycle, so it's a normal winter. And you notice our median snowfall is about 9.5 inches or so. But during an average El Nino, the snowfall does increase to about 13.6 inches. So there is a bit of a signal here, like you saw in the previous map, that during El Nino winters, we can see more snowfall on average. But again, look at the year-to-year variability. Look at the individual graphs. So you see some years where we did see a lot of snowfall during El Ninos, and you see other winters, some back-to-back, where we saw hardly any snowfall. So the bottom line is, winter weather here in central Virginia is really variable. And even though there is a signal this winter that we could see a little bit more snowfall than what we normally see, the variability makes it kind of tough to say, is it 100%? Definitely not. But we'll see how it plays out. So that's across basically Richmond and what we expect across central Virginia. And we see the exact same signal, even a little bit stronger. If you were to push a little bit further to the northwest towards Louisa and Charlotte, you would see even a better increase probability of basically more snow as you get even further inland from the coast across the Piedmont and the eastern slopes of the Appalachians. Now, getting down towards Norfolk, looking at the exact same types of data. Here in the middle, the temperature here on the left-hand side during a normal winter versus El Nino. Again, you really don't see much of a difference at all at Norfolk. Maybe even slightly warmer, a half degree warmer during El Nino on average than what it is, say, in a normal winter if everything's left to its own devices. So very, very, very weak signal that El Nino is slightly warmer, but not a huge signal here. And the same thing's true for snow. Notice you have lost the snow signal. You did see an increased probability of more snow in Richmond during El Nino, but when you get to the coast, that signal has really kind of vanished. Really, the snowfall difference, 5.6 is the median snowfall in a normal winter. During El Nino, just slightly less at 5.1, almost really in the noise. So not a lot of variability here. And again, these coastal storms, it really depends upon how close the storm tracks to the coast. So if the storm is too close to the coast, Norfolk and Tidewater get rain. Maybe Richmond's kind of gets rain changing over to snow, and then all of a sudden Louisa is pure snow. So the closer the storms track to the coast, the warmer it is at the coast, and so the less snowfall we see. So we'll see how this plays out. Again, you notice a huge amount of variability in Norfolk. Some years with El Nino were snowy, some years hardly any snow at all, and then that's true across the board. If you do look at the El Nino cycle here versus the one here in the middle where it's normal, notice you do not see quite as many of the big blue bars. So maybe there's a slight decreased probability of at least snowfall across Norfolk, but the signal is really honestly pretty weak. Going a little bit further up to the north in Salisbury, again, a lot of the same signal that we saw in Richmond. In fact, in El Nino, in Salisbury, it's a little bit different. Notice how the average temperature between a normal winter, 37.7, and then during El Nino, 36.7, it does showing it being a little bit cooler during El Nino on average. And it's because you're a little bit further north now, compared to Richmond and Norfolk. So the air is colder. You have the more increased storminess potentially. With the increased storminess comes more clouds, more precipitation. It pulls down more cold air from the north because they are further north. And so maybe a slight signal that during El Nino up in Salisbury, it could be a little bit cooler than normal. Not a strong signal, but a weak one. Same thing with snowfall. You notice how between here, the middle graphic here is showing a normal winter, about 10.6 inches, where during an El Nino looks like about 13.4. So on average, we do see a potentially increased amount of probability of snowfall in Salisbury, Maryland during El Nino. And again, it's closer to the coast, it's further north, but because it's further north than Norfolk, it's more cold air to work with sometimes. And so we do see maybe a little bit stronger signal there for increased snowfall because it is a higher latitude. And by the time the nor'easter or storm gets up that far, it does have more cold air to work with and can produce a little bit more snowfall. So we're talking a lot about temperatures and temperature variability. And again, the timing between the moisture that comes north with the coastal system and the cold air coming south, where those two collide, and how the weather pattern is set up there has a lot to do with what's known as the North Atlantic Oscillation and the Arctic Oscillation. So we've been talking about El Nino or the Southern Oscillation. That's really the driver for our precipitation. But our temperatures are driven a lot by what's called the North Atlantic Oscillation. And we talk about that a lot more in part 2 of our YouTube series. I put the link up here. I'll put it in the comments below. But in the part 2 of Whether You Want to Know or Not winter series, we dive deep into a North Atlantic Oscillation, what drives our cold temperatures, and that's much more variable. You guys know sometimes we can have a week or two that's really cold, and then maybe the next week or two it's actually fairly warm, maybe above normal. A lot of temperature variability, and that's driven by what's going on out in the Atlantic Ocean and over Greenland and Iceland, believe it or not. So learn more about the North Atlantic Oscillation by going to part 2 of Whether You Want to Know or Not. And so that gets us into just kind of our average snowfall. We'll talk more about that in part 2 as well. Kind of talking about, what is the average? What is normal? What's normal for Norfolk? The median snowfall is 3.4, but if you actually average everything out, it's 6.2. So what's right? Honestly, statistically, 3.4 inches is actually what we would consider to be more of an actual normal snow year for Norfolk. Where in Richmond, about 7.8 we consider to be normal up there. And by the time you get up to Louisa, about as high as 12.7 is kind of our median snowfall amounts. But we talk more about this on median versus averages, the variability of snowstorms, the North Atlantic Oscillation. We get a lot more into that in part 2 of Whether You Want to Know or Not. So there's some great websites out there to check out. The official Climate Prediction Center Outlook is out there. You can visit their website. You can also go to their YouTube page and visit basically their outlook, their winter outlook for the whole country on YouTube. Again, you can track the latest El Nino and La Nina conditions on the Climate Prediction Center's webpage, in addition to the North Atlantic Oscillation, which we will talk about more in the next series. So definitely check that out. And some acknowledgments we want to make sure that we give to this is not only the outlook from the Climate Prediction Center, but a lot of the local statistics comparing the El Nino, La Nina to normal, and how those impact our winters was compiled by Larry Brown, our climate program leader. And he does a great job keeping all of our climate records up to date and trying to relate them to exactly what's happening in the bigger climate world. So once again, thanks for joining us on Whether You Want to Know or Not.